Imagine as a kid, you walk into a classroom and you see robots all over your desks. And if the child is not excited immediately, I'm not sure if you walk into a toy store, I'm guessing they won't be excited either.
People have compared the current model of education, where students come in, get knowledge, walk out with knowledge, to a model that was developed for and designed for and really suited for the industrial age, where the purpose of the educational system was to make sure that people were prepared for factory work. And what is factory work? Factory work means working very much like a machine. That is absolutely not what people's role is today. We have machines to do the machine work. And so educating people to do the machine work is both not interesting to them and largely an unproductive use of time.
The purpose of the Robotics Academy is to develop an educational outreach arm of the Carnegie Mellon Robotics Institute, which develops a lot of sort of large-scale technologies on main campus here in Pittsburgh. So what we do is we take those same technologies and we try and make them in an applicable form for students and teachers to be able to sort of teach those same ideas in their classroom, using different types of sensors and robots to eventually turn into teaching the concept of STEM, which stands for science, technology, engineering, and mathematics.
It would be difficult to predict what the fastest growing innovation will be 5 years from now, but we can, with more confidence, we can predict that it's going to involve computer science, embedded systems, applied mathematics, and engineering design.
You can learn all of the same concepts that robots can teach on paper. You know, if you take a look at a wheel, you can figure out that there's a circumference to that wheel, but you don't ever get to see a physical application of it. Being able to take those concepts that are usually very abstract and then be able to show students that, well, if I tell this wheel to rotate and it goes this specific distance, we can calculate and figure out why it went that distance.
Our materials are designed to be student-driven, but teacher-monitored.
So one of our outreach things that we do is we go to the Science Center here in Pittsburgh, and we'll do like an hour workshop with middle school kids, where we'll take a little maze and we'll take the robots and we take candy bars. And we always say, all right, the first person to finish the maze is able to do it. But the caveat is that, you know, there's usually 2 of us that go and they have to run the maze so that both of us see it, and we'll be on each different sides of the room. So what happens is that the robot will run perfectly fine for the first time and it fails miserably the second time. They get so angry because they're like, we're so close. It's a good way to teach students that not everything is going to go correctly.
Lots of classrooms don't have enough robots for students. So what we try to do with the Robot Virtual World software is emulate exactly what the student does with a real robot, but in a simulated environment.
CS2N is the place where teachers and educators can go and get activities for their students, and a lot of the stuff we put out for free.
All of the technology that we're developing will phone home to CS2N so that teachers can log in and actually see the exact progress of all of their students.
We have what's called badges or achievements. That's exciting because when they get, I got 5 questions right, they get pretty excited about that.
You know, a lot of the critical thinking and problem-solving skills that you develop working on a robot challenge or a problem, you're able to apply those in real life.
Robotics is an easy way to get them excited and to get them into and using those skill sets that they need.